Hello, everyone. Thank you for joining us for the first episode of this workshop series. Today's episode is using AWS Systems Manager as a foundation for operationally excellent workloads. My name is Eric Weber. I'm a Senior Specialist Solutions Architect for our Cloud Management Services here at AWS. So to get started with an agenda of what we're going to be covering within this episode, first we're going to configure some CloudFormation stacks to set up the workshop with some stand-up resources and some testing resources. And then we're going to flip back to the presentation to go over an overview of what is AWS Systems Manager. And then we'll be talking about various capabilities within Systems Manager, including Session Manager, Run Command, Distributor, State Manager, Automation, and Ops Center. So to get started with the workshop, we're going to go to the GitHub repo. And within the instructions, first we're going to go through, this is the overview page where it displays what is the corresponding links to our user guide documentation for each of those capabilities that I mentioned. It also includes the learning objectives of what we're going to be working towards today. So to get started, we're going to go into the first section here. And we're going to scroll through here, which has some introductory information, should you ever want to review it after today's workshop. And then to get started, we're just going to go through this first section for creating a test EC2 instance. And to do that, we're going to open up this CloudFormation template. We're going to select raw. And then we're going to copy and paste this information into a notepad. So what this template is going to do is going to create some test resources that we can then use as we're going through this overall workshop. A simple diagram would be that it's going to be standing up a VPC with a subnet with an Amazon Linux 2 EC2 instance launched into those VPC resources, which is then going to communicate with our Systems Manager endpoints over the public internet using an internet gateway. So we are then going to save our notepad file. And then in the AWS Management Console, we're going to go to CloudFormation. We're then going to select Create a Stack, and we'll select Upload a Template File and choose that template that we just saved locally. Go ahead and hit Next here. And we're going to fill out some parameters in here, which you can always refer to within the GitHub instructions. So for the name, we're going to name it just OE-workshop. And this parameter here, this latest Amazon Linux AMI ID, what we're actually using here is one of the capabilities of Systems Manager called Parameter Store. And this in particular is a public parameter which can be referenced from services or from the CLI or API calls. And what this allows you to do is pass in this value, and the service will then resolve what is the latest available Amazon Linux 2 AMI ID. So if we hit Next here, we're then going to scroll through, select Next again. And then on the review page, we're just going to make sure that we select, that we acknowledge that CloudFormation is going to create a corresponding IAM resource, and then select Create Stack. So this is going to take a couple moments just to stand up those provisional resources. So we're going to go back to the presentation now and talk about that overview of AWS Systems Manager and some of those capabilities. So to talk at a high level of what are some of the benefits of using AWS Systems Manager, you can see them displayed on the screen now. So AWS Systems Manager is going to help shorten the time to detect problems and help you quickly view operational data for groups of resources. So you can quickly identify any issues that might impact applications that use those corresponding resources. Resources within your accounts can be grouped by applications, application layers, production versus development environments, or really anything that makes sense within your environment. Systems Manager presents these operational data for your resource groups in a single and easy to use dashboard, so you don't have to navigate between multiple different AWS consoles. For example, if you have an application that uses Amazon EC2, Amazon S3, and Amazon RDS, you can use Systems Manager to create a resource group for that application and easily see the software that is installed on your EC2 instances, any changes that have been made to those S3 objects, or database instances that are stopped. Systems Manager also allows for easy-to-use automation and enables you to automate operational tasks that can help make your teams more efficient. With automated playbooks, along with the rich text descriptions, you can reduce human error and simplify maintenance and deployment tasks on AWS resources. You can use predefined automation playbooks or build your own to share for common operational tasks, such as stopping and restarting an EC2 instance. And Systems Manager also has built-in safety controls, allowing you to incrementally roll out new changes and automatically halt the rollout if any errors occur. It'll also help you improve visibility and control by helping you easily understand and control the current state of your resource groups. With Systems Manager, you can view detailed system configurations, operational system patch levels, software installations, application configurations, and other details about your environment through the Systems Manager Explorer and inventory dashboards. Systems Manager is also integrated with AWS Config, so you can easily view changes across your resources as they occur over time. And then Systems Manager can also help manage hybrid environments as well. So you can manage both servers running on AWS as well as in your on-prem data centers through a single interface and single service. Systems Manager securely communicates with a lightweight agent installed on your servers to execute management tasks. And this will help you manage those resources for both Windows and Linux operating systems, whether they're running on EC2 or on-premise. And lastly, Systems Manager is going to help maintain security and compliance. By scanning your instances against your patch configuration and custom policies, you can define patch baselines in order to maintain up-to-date patching levels. You can also enforce firewall policies. You can remotely manage your servers at scale without having to manually log into each individual server, which we'll talk about when we go over to the run command section. And Systems Manager also provides a central store to manage the configuration data, which is those parameter store functionalities I was referring to earlier. This allows you to separate your secrets and configuration data from the code itself, which means that the code is not hard coding passwords and passing them as plain text, and rather using the Systems Manager service to resolve those securely. To take a quick look at what are all of the capabilities within Systems Manager, they're listed out here and they're broken up into 4 different sections, being operations management, application management, change management, and node management. Like I mentioned previously, today we're going to cover primarily capabilities in the node management section. So those are going to be session manager, run command, distributor, state manager. And then we'll also be covering automation in the change management section and Ops Center in the operations management section. So to get started with Session Manager provides secure and auditable instance management without the need to open inbound ports within your security groups. You no longer need to maintain bastion hosts or manage SSH keys. Session Manager makes it easy to comply with corporate policies that require controlled access to instances, strict security practices, and logging capabilities for commands that are executed within your sessions that are being established, while still providing the end users with simple one-click cross-platform access to the managed instances. Some of the benefits of using Session Manager are that you have centralized access control to instances using IAM policies. Again, you no longer need to open inbound ports, nor do you need to manage bastion hosts or SSH keys. You have one-click access to instances from the console and from the AWS CLI. You can establish port forwarding connections to remote ports on your managed instances. It has cross-platform support for both Windows and Linux. And then you have full logging capabilities for the session activity. And then you can also improve your security posture of your managed instances for resources that are in fully private VPCs or subnets by standing up VPC endpoints and communicating directly with the service. Whereas Session Manager is an interactive based capability of Systems Manager, we're next going to talk about run command, which is more of the non-interactive method of remotely managing these resources. So run command enables you to automate some common administrative tasks and perform ad hoc configuration changes at scale within the operating systems of these managed instances. You can use run command both from the AWS console, the AWS CLI, or just any of our SDKs. And administrators may want to use run command to perform tasks on their managed instances. Typically, we see customers using these for installation or bootstrapping applications and managed instances post-launch, or building out a deployment pipeline, capturing log files when an instance is terminated from an auto-scaling group, joining instances to an Active Directory domain, and many more common use cases. By using run command, you can also apply software updates and edit local operating system configuration settings that may need to be put in place. And the access to run command is, again, similar to Session Manager, going to be controlled via IAM. So you can ensure that the users that are leveraging run command only have access to the appropriate command documents and actions, as well as access to the appropriate managed instances. Next, we're going to talk about Distributor. So Distributor is a way to securely distribute and install software packages. So on the right-hand side, you can see that the Owned by Amazon tab is selected, where AWS provides several different packages that are available to be distributed out to these managed instances. In this case, we're going to be using Distributor later on in the workshop in order to install the Amazon CloudWatch Agent. But what you can do is customize Distributor, and you can create your own software packages so that you can then deploy them out to your managed instances across your entire environment. These packages that you end up creating, you can share them across your AWS organization by sharing these out with your other accounts as needed. And as part of the packaging process, you can group up multiple different operating systems software installation files as a single package, and then deploy them out across your entire environment. And the Systems Manager agent will then make the determination of which corresponding package you should use. And then again, similar to both Session Manager and Run Command, you can restrict access to which packages are allowed to be used by corresponding users, and then you have full CloudTrail logging of when these operations were being initiated. And then the last benefit of using Distributor is that you can also configure these operations to be performed on a routine basis, so you can ensure that your software is installed and kept up to date. So building off of that last portion that I was just mentioning, we're next going to talk about State Manager, which is the way to set up configuration management within Systems Manager. So when I was mentioning that scheduled basis of using Distributor, what it's really going to leverage is this State Manager capability, which helps keep your managed instances in that appropriate desired state that you end up defining. So we can either use State Manager associations to install our Distributor packages, or we can leverage State Manager for several other different types of use cases, including applying common third-party configuration management tools like Chef recipes, PowerShell DSC modules, Ansible playbooks, Chef inspect profiles, or just generic PowerShell scripts and bash scripts that you may already have in use. And the intention of using State Manager is that you're going to be performing these on a routine basis to ensure that that configuration is kept in place. And should a managed instance ever drift from that defined state, it'll then report back the overall compliance information, which we can then quickly identify which of our instances have drifted in order to then go about remediating them. And State Manager is also State Manager can also be used for bootstrapping instances. So when you launch new EC2 instances and they check in with Systems Manager, and you need to apply some configuration at launch or post-boot, you can then go ahead and create these associations, which can put those additional bootstrapping processes in place. So at the bottom there, you can see just an example being that you can use State Manager associations with CloudFormation to install software on those instances that are being provisioned through the CloudFormation stack. And then State Manager, again, of course, integrates with AWS CloudTrail, so you can keep a record of when all of those executions are being performed, so you can always go back and review. You can also set up Amazon EventBridge to track state changes of your State Manager association, so that you can then kick off other actions as needed, such as notifications to the appropriate individuals when these state changes occur or when these resources drift. And then you can also store detailed command output in Amazon S3. So previously, we've been talking about management within the operating system of our managed instances. But now we're going to talk about automation, which helps us perform actions both within the operating system through the use of run command, or we can also interact with the AWS infrastructure layer. So automation helps you build out these automated workflows that can configure and manage instances as well as AWS resources. You can create these custom workflows or use predefined workflows that are maintained by AWS. And when these workflows are being performed, you can set up notifications so that you are alerted based off of particular events that take place. You can always monitor the current progress as well as the execution details by using the management console or querying our APIs. And some of the use cases for leveraging automation are around automating those common IT tasks that you may have within your environment. So anything that is being performed manually today, you may want to look to leverage existing AWS provided automation documents or potentially converting them into a custom automation document. So automation can help simplify complex tasks by offering those one-click automations for those common tasks within your AWS environment, such as creating golden Amazon machine images or AMIs, or recovering unreachable EC2 instances. And it'll also help enhance your operational security by using delegated administration, so you can restrict or elevate user permissions for various tasks. Automation runbooks also help you share best practices, as these resulting runbooks that you end up creating, you can then share out with your other accounts within your organization. So you can ensure that best practices are being put in place as part of the day-to-day operations. Within an automation runbook, we can also include approval actions. So prior to the actual workflow being performed, an appropriate individual can then be notified that they need to go ahead and review the automation runbook to determine if it should go ahead and proceed with the process defined. You can also include PowerShell and Python script directly in line within the overall runbook. So if you have those types of scripts available, you can include them within a custom document so that they're executed within the service without having to stand up underlying resources to run those scripts. So on the right-hand side, you can see an example AWS provided document, which is related to AWS config. So in this case, it is for the AWS config rule to check if an S3 bucket has public access allowed. In this case, we want to ensure that our S3 buckets are not allowed to be made available publicly. So we can execute this automation runbook in order to go ahead and review our S3 bucket and ensure that public access is not allowed. When we're talking about automation, automation has deep integration with Ops Center, which we'll also focus on within the workshop when we go through the instructions. And Ops Center is a way to view, investigate, and resolve operational issues that are taking place within your AWS environment. So it enables a standard and unified experience for remediating those issues as they're related to your AWS resources, whether they're those managed instances or infrastructure resources. So it helps you improve the time to actually resolve issues by aggregating data from multiple different AWS services, so you don't have to hop between multiple different AWS consoles. And it also offers several other benefits, such as viewing service-specific information and contextually relevant data for these ops items that are automatically generated both by CloudWatch events or CloudWatch alarms, which we'll take a look at later on. When you are working with these ops items, you can specify Amazon resource names or ARNs of related resources, which will then create deep links so that users can quickly navigate between the related resources. And Ops Center also uses built-in logic to help you avoid creating duplicate ops items when these are created by those automated processes. And you can view details and resolution information about similar ops items. It'll group up those as needed. And you can quickly view information about, as well as execute those automation runbooks that we were talking about earlier in order to resolve issues quickly. And Ops Center also has bidirectional integration with Jira Service Desk, and it also has integration with ServiceNow. So that was a quick overview of some of the capabilities that we'll be taking a look at today within this episode of our workshop series. Some of the other features of AWS Systems Manager as a whole are listed out here, such as being available in all AWS regions, including GovCloud. When we are talking about performing this row management functionality on our managed instances, and you are talking about EC2 instances, if you are using AMIs that are provided by AWS for Windows, Amazon Linux 2, Mac OS, or Ubuntu, the SSM agent will be pre-installed on those AMIs. Like I mentioned previously, you can access and stand up VPC endpoints, which leverage AWS Private Link in order to communicate directly with the service, so you no longer need internet access for your EC2 instances. And Systems Manager, like I mentioned before, has deep integration with other AWS services, like I previously mentioned, being AWS config, Amazon EventBridge, AWS CloudTrail, and AWS IAM. So with that being said, we're going to go ahead and move on into the hands-on portion of the workshop now. So back in our AWS Management Console, we can go ahead and refresh our CloudFormation stack here, where we should see that it has successfully finished deploying out our resources. If we go over to the Resources tab, we can see those various resources that we were talking about earlier that are created by that CloudFormation template. So what we will do now is go ahead and review the EC2 instance just to talk about how we can manage our EC2 instances using Systems Manager. So in the EC2 Management Console, we can see that our EC2 instance in this case is using Amazon Linux 2, which means that the SSM agent is pre-installed. The CloudFormation template also created an IAM role so that our instance has the appropriate permissions in order to communicate with the Systems Manager endpoints. And in this case, the EC2 instance has a public IPv4 address, so it's communicating with the Systems Manager endpoints over the public internet. So if we open up the IAM role itself, we can see a couple of different policies that are being added to our IAM instance profile. The first one is the Amazon SSM Managed Instance Core. This is the minimum required policy in order for an EC2 instance to check in with AWS Systems Manager. Since we're going to be deploying the CloudWatch agent as well as configuring the configuration file for the agent, there are two additional policies that have been added. So the first is the CloudWatch Agent Server policy, and then the CloudWatch Agent Admin policy. So in this case, because we are defining the configuration file and then placing it into Systems Manager parameter store, we do need to add this admin policy. Once we have that configuration file in place and we are ready to deploy it onto our other managed instances, we can then go ahead and remove this policy as it would no longer be needed. So we're going to go to the Systems Manager console now. And in the Systems Manager console, just to confirm that our EC2 instance is checking in, we're going to go to the Fleet Manager section, where we can see that our instance is now checking in with Systems Manager. And then to get started with deploying the CloudWatch agent, we're going to go ahead and select Distributor in the left-hand side. And here we can see those packages that are made available by Amazon that you can leverage to install on your managed instances, either on a one-time basis or on a scheduled basis. So for now, we're going to select the Amazon CloudWatch agent and then select Install on a Schedule. This is then going to bring us to the State Manager console and specifically the Create Association process. So we're going to fill out some information here in order to install the CloudWatch agent. So for the name, we're just going to enter CloudWatch agent-install. Our document, AWS configure AWS package, will already be selected since we came in through the Distributor console. When we go through the parameters section, we can also see that our action is to install the CloudWatch agent with the name already being specified here. So if we keep scrolling, we're going to go through the target section. When we are standing up the State Manager Association, run command task, or automation task, we can target our resources through a couple different ways, whether those are based off of resource tags that are added to our instances. We can choose instances manually and based on their resource ID or resource groups. And then for State Manager specifically, we can also choose to specify all instances, meaning anything that is checking with Systems Manager. For now, we're just going to select Choose Instances manually and then select our EC2 instance from the drop-down list. In the schedule, we're just going to select cron/rate expression builder, or specifying it in expression directly. And in here, we're going to specify rate of 1 day. As part of State Manager associations, you can also add a compliance severity so that you can quickly identify which resources are non-compliant, what is that overall severity of their non-compliance. For now, we're just going to omit this and just select Create Association. So this is now going to then target that EC2 instance which we created using CloudFormation and install the CloudWatch agent. So we hit View Details here. We can go to the execution history, and we can see that the task is currently in progress. if we open up this execution ID, we can then see some more details about it, which it looks like now it has successfully installed. If we want to review the resulting output of the corresponding run command task, we can select the output option here, which will bring us over to the run command console. And in here, we can then expand step 2 and see that the CloudWatch agent has successfully been installed. So if we go back to the State Manager console and we refresh our association page, we can now see that our association is in a successful status. If we go to the resources, we can see that our EC2 instance last applied the association today and now is in a successful state. So now that we have the CloudWatch agent installed, we are now going to go ahead and create a configuration file using the CloudWatch configuration or the CloudWatch agent configuration wizard. And to remotely connect to our managed instance, we're going to leverage Session Manager. So from the Session Manager console, we're going to select Start Session. We'll select our instance from the list and then hit Start Session again. So this is going to establish that interactive session where now I can run commands on my managed instance as needed. So we're going to run the command now to go ahead and start the wizard. And in here, we're going to answer a series of questions in order to build out the configuration file for our CloudWatch agent. So in this case, we are on a Linux instance. This is an EC2 instance. We're going to run it as the root user. We are not going to enable statsd, nor we're going to be monitoring metrics using collectd. We will be selecting that we want to include host level metrics. For this option, we're going to select no. And then we are going to include add EC2 dimensions. In this case, we are just going to go with the default value for collecting metrics. And then the type of metrics that we actually want to include, we're also going to just select the default basic configuration. So if we take a look at the current configuration file as it has been created, we can see that the metrics that we're looking at and that are going to be collected by the CloudWatch agent are disk usage as well as memory usage. So we're going to answer that we are satisfied with the configuration file. In this case, we do not have any existing configurations files, so we'll answer no. For the workshop, we're just going to omit logging or monitoring log files, so we can answer 2. And in this case, it'll report back the config again, and then it'll ask, do we want to store the config in SSM parameter store? So we do want to include that. The name of the parameter, we're just going to go with the default again, which is Amazon CloudWatch-Linux. We will be storing it in the US East 1 region. And then for the credentials to be used, these are going to be those credentials that are associated with the IAM instance profile. So we're going to select yes. And then once we do that, the configuration wizard will go ahead and exit as it was able to successfully put the config over in parameter store. And if you need to review the answers to any of those questions, they are available on the GitHub repo. So you can see the options that were selected. So now that we successfully created that configuration file, we're going to go and view it within parameter store, and then we'll use that to actually configure the CloudWatch agent on this managed instance. So for now, we just can go ahead and hit terminate here and go back to the Systems Manager console, where we'll then open up parameter store. So in parameter store, we can see our parameter that was placed here by the configuration wizard. So if we open this up in the value section, we can then see the appropriate CloudWatch agent configuration file that we can then use to configure the CloudWatch agent on this particular instance, as well as if you're looking to use this configuration file for other managed instances, you can also reference it there. So now that we have our configuration file ready to go, we're then going to create another State Manager association to put this configuration in place. So on the State Manager Associations page, we're going to hit Create Association. We're going to fill out some details again. So in this case, we're going to name this one CloudWatch Agent Configure instead. In our document list, we're going to search for Amazon Amazon CloudWatch. And we're going to select the Amazon CloudWatch-Manage Agent document. In our parameter section, we're going to leave several of the defaults for the action, the mode, and the operation, or the optional configuration source. And in the configuration location, we're going to enter in the name of our parameter over in parameter store. The parameter was named Amazon CloudWatch-Linux, and this name is case sensitive, so be sure that you enter it in as such, and it reflects the name of the parameter that was placed. And then we'll leave the remaining default values as well in order to restart the CloudWatch agent with the new configuration. And again, similar to this previous process, we're going to select our specific managed instance manually. And then for our cron expression, we'll be specifying a rate-based expression of 1 day. And then we'll go ahead and hit create association. So again, this is going to take just a moment just for the configuration file to be brought down to the managed instance. And it looks like by the time that I open this, it has already succeeded. So now our CloudWatch agent has been successfully installed on our EC2 instance as well as configured. So it's going to start reporting metrics to CloudWatch, which we can then go ahead and review within the CloudWatch console. So that is the end of the first section of the lab instructions. So we're going to scroll through here and then go to the next section. So in the next section of the workshop, we're going to create a CloudWatch alarm. We're going to view those metrics that were gathered, and then we're going to trigger the alarm, which will in turn create an ops item over in Ops Center. So to get started, let's go over to the CloudWatch console. And in the CloudWatch console, we're going to go to the metrics section. In here, we'll select the CW agent namespace, and then specifically the image ID, instance ID, and instance type metric. In here, we can then see our EC2 instance. In here, after a couple minutes, we'll start seeing metrics that are being posted for memory usage on our EC2 instance. So while we're waiting for those metrics to be populated, we're going to go to the alarm section. In here, we're then going to hit create alarm. We will then select our metric. We're going to select that same metric that we were just looking at. So selecting CW agent first, selecting image ID, instance type, and then selecting our specific test instance for the memory usage. So let's select metric here, and then we're going to scroll through down to the conditions page or conditions section. And in here, we're just going to put a simple memory usage check for 15%. So when the instance is using more than 15% of the memory available, it's going to go ahead and flip the alarm into the alarm state. Of course, outside of the workshop, you may certainly want to provide a higher value, but just for the purposes of the demonstration today, in the hands-on portion, we're going to specify a relatively low value. So we're going to hit the next option here. And in our configure actions section, we're going to remove the SNS notifications. And instead, we're just going to hit add for our ops item integration. So in this case, we're going to leave the default severity of medium and then specify performance as the category. And then hit next. And then here we'll be specifying a name for our alarm itself. In this case, we'll just specify memory used alarm. And then for a description, enter in something relatively generic, such as this alarm is configured to trigger when memory usage exceeds 15%. We'll go ahead and hit next, and then we can review what we have specified so far as part of the process, and then scroll down and hit create alarm. So this alarm is going to start in the insufficient data state until it has enough information from our metrics that are being posted by the agent in order to determine if the alarm is in an OK state or an alarm state. So if we go back to our metrics tab, we can refresh this graph here. It looks like our first data point of the memory usage from the instance has been posted now. So it looks like the current memory usage at that point in time was 10.25. So if we then go back to our alarm here, if we refresh this in a moment, we'll start getting some more information and more data points. And then our alarm should change into the OK state. And while we're waiting for that, we can also go back to our metrics page and take a look at the other metrics that are being posted as part of that default or that basic configuration file. So it's going to be including disk usage percentage for various devices on the operating system and paths. So you can always add these to the graphs as well if you would like to see some of that disk usage. So our alarm has now changed into the OK state. So we can see that the current memory usage on that EC2 instance is under that threshold of 15%. So the alarm is in an OK state. And if we scroll through here, we can see some of the details about it, as well as what are the corresponding actions should anything occur. And then what is the overall history of what is taking place. So now that our alarm has been configured and set up and is in an OK state, we're now going to leverage some other Systems Manager capabilities in order to trigger a stress test against this test instance in order to consume some memory, which will then change our alarm state to it'll change our alarm into the alarm state, which will then create that corresponding ops item. So we're going to go back to the Systems Manager console now. And then on the left-hand side, we're going to scroll down to run command. We're then going to hit run command. And in the documents list, we're going to search for AWS run shell. In the resulting list, we'll hit run shell script. And then in our command section, we're going to copy and paste the commands that are specified here in the repo instructions. So we'll scroll down to our section where we're going to copy and paste these into the command parameters. So in this case, like I mentioned, we're going to install the stress package on our test Linux instance, and then we're going to run the stress package in order to consume some memory, which will then in turn trigger our alarm. So we're going to scroll down and select our managed instance. We're going to go ahead and hit run. So this is going to go ahead and perform those resulting commands that we passed in through those command parameters and begin the stress test. So in a couple moments, we should then see the graph update as well as the alarm change into the alarm state. So as we wait for our alarm to flip into that alarm state as a result of the stress test, some things to call out here is that specifically when we're creating an alarm, we can see that we're only waiting for a single data point where the memory usage has been over 15%. Alternatively, what you can define is the alarm is going to wait for multiple data points to ensure that that it wasn't a single spike in memory usage that has then kicked off or triggered the alarm. In addition to creating these ops items through our CloudWatch alarm actions, we can also include other notifications like we saw with the SNS portion. We can also use Amazon Event Bridge to kick off other actions as part of the alarm state changes. So we'll take a look at that while we are waiting for our events to change and the alarm state to change. So in here, we could create a new role and we can select event pattern. And then we can see the events that are being posted to our account. And then in here, we can specify CloudWatch, and then specifically when one of our alarms changes their state. What this allows us to do is then kick off targets, which can be various functions and services within AWS, including Lambda functions that we want to initiate, Systems Manager automation runbooks, create those corresponding ops items, or even initiate run command task. as well as several other different targets that we may need to kick off as a result of an action that has taken place within our account. So if we go back to our metrics here, we should see that memory usage is starting to spike. So in just a moment, we should then see our alarm change into the alarm state. So now we can see that our CloudWatch alarm has changed into the in-alarm state as our memory usage has now spiked above our threshold that we defined as part of the overall alarm. So what this means is that we can then go back to the Systems Manager console, where we can then see that our ops item has been created as part of those alarm actions that we defined. So we're going to open up Ops Center here. And in this case, we can see that the ops item is grouped by that specific source of the CloudWatch alarm itself. So if we go over to the ops item, we can then open it up and start seeing some information about the related resources, as well as add our EC2 instance to this. So in this case, I'm going to take our EC2 instance ID, go back to the ops item, and then select Add Related Resource. We'll select EC2 instance from the list, and then specify our instance ID and hit Add. So now that we've added our corresponding resources to this particular issue, we can then go to the Related Resource Details tab and see a lot of different information about other AWS services that Ops Center will automatically aggregate for you. So in here, we can expand these various sections. So if we look at the history, we can see when the alarm changed state. If we go to the CloudTrail logs, we can see some of those other information, such as related API calls that were being made. If we flip to the EC2 instance instead, we can see generic CloudWatch metrics that are being populated that are available for all EC2 instances. If we scroll down, we can then see some other information, such as the resource description, which is going to be pulling information from the EC2 console. If we keep scrolling down, we can see information about those current CloudWatch alarms, which we were just taking a look at. If you have AWS config enabled, it'll also pull in data from config. Again, CloudTrail logs for this particular instance, and then information about the CloudFormation stack that we stood up earlier. So again, Ops Center and these ops items are going to help aggregate all of this information for you so that you can then go about troubleshooting and triaging these issues that are taking place. So in this case, because I'm looking at an EC2 instance, it is a managed instance, I could just select this option to open up that Session Manager console and have a session be established. But in this case, since we know exactly what is going wrong, that stress command is currently being executed on our managed instance, what we're going to do is just go ahead and select our EC2 instance here, and then scroll down to the runbook section, where we're going to specify that we just want to go ahead and bounce the instance and perform a reboot operation. So we're going to filter for AWS-restart, and then we'll select that document from the list, where we'll then go ahead and execute. And then we're going to hit execute again. So this is going to start a process to go ahead and restart the EC2 instance. And then once that instance successfully has been restarted, it'll no longer be running that stress command. And then our CloudWatch alarm should return back to that OK state. So this process is going to restart our EC2 instance, which we can then review the execution logs here. So we can see that our instance has already been successfully stopped. And it's going to bring the instance back up now. And once it passes those instance status health checks, it'll report back that the instance has successfully been restarted. All right, so if we look through our automation runbook now, we can see that the instance has successfully been started back up. So if we go back to our Ops Center tab, we can refresh the page. We can see the successful status over here as well. So now let's go back to the CloudWatch console, where we will also refresh this page. And in just a moment, we should then see our alarm return back into the OK state. So we can see that memory usage is starting to return back to the normal average. So our alarm will then return back to the OK state, at which point we can then go ahead and resolve our ops item. So now our CloudWatch alarm has returned back into the OK state. So the issue has been successfully resolved. So we'll go back to Ops Center, and we'll go ahead and resolve our ops item. And with that being said, we have now successfully completed this section of the workshop. So we'll go ahead and proceed with tearing down the resources that we stood up. So the first step is to remove the CloudFormation stack. After that, we'll delete the CloudWatch alarm, and then we'll delete some of the Systems Manager resources that we ended up creating. So to go back to the management console, and specifically the CloudFormation console, we're then going to delete our CloudFormation stack that was created. We'll hit delete here. And while this is deleting the resources, we can go ahead with the other steps, such as deleting the CloudWatch alarm. So from our alarm, we're then just going to select delete here, and that'll remove the alarm. And then we'll go ahead and go back to our CloudFormation stack, where our resources will be removed. So to tear down the Systems Manager related resources, we're first going to go to Parameter Store. We're going to select that parameter that was created for the CloudWatch Agent configuration and just go ahead and hit delete parameter. We're then going to go over to State Manager, and then we're going to delete those two corresponding associations. And now we are successfully done with the first episode of this particular workshop series. So thank you for attending. Please feel free to ask any questions at this point.